Embedded intelligence in EV, enabling safer systems, smarter motors, and faster product launches. Good evening, everyone. Good evening, Mr. Sawant. On the behalf of DIYguru team, I warmly welcome you all to today's masterclass on embedded intelligence in EV, enabling safer systems, smarter motors, and faster product launches. We honor that today we have Mr. Sawant with us. Mr. Sawant brings extensive industry experience in embedded systems and electric vehicle technologies and has worked closely on developing intelligent, safe, and scalable EV solutions. His expertise spans areas such as safety system, motor intelligence, and embedded systems in the EV ecosystems. So, our today's session will offer a valuable insight into how embedded intelligence is shaping the future of electric vehicles, enabling safer systems, smarter motors, and faster product launches. This session will highly beneficial for the students, industry professionals, and EV enthusiasts as like. Before we proceed, I kindly request all the participants to fill out the attendance forms that I pinned in the chat box to mark your presence in the session. Please note that Mr. Sawant will be open for a question and answer session at the end of the masterclass. So we encourage you to be ready with your questions and queries. So without further delay, it's my pleasure to invite our speaker for today, Mr. Sawant. Over to you, sir.
Hey, hi Shreyansh. Thanks for this opportunity. Good evening, everyone. Mostly, I'm assuming everyone is from India. So let's start. Let me share my screen. Okay, I'm assuming it's visible. Okay. So thanks again, and let's jump into this. So I'm Kumar Sawant. Actually, so I am currently the founder and director of Stuffbits, and Stuffbits with the collaboration with the Pragmatic Design Solution. It's a UK-based company. Okay, I'll directly jump into the content now. Okay, so I start with so most of I assume are people who are students who are they haven't started their career yet. So I wanted to highlight my career and what I learned, how I grew, and why I think it's optimum career I had. Okay, based on the initial start I got from the industry. Okay, and what different roles I had to play. That will give you idea. Okay, I don't want to go into actually like the marketing terms, like how the EV is good and bad, or how that will actually progress. Definitely it's going to progress, but how you can play a role in that particular domain, okay, or ecosystem. So let's start with myself. So I started my journey in 2010. I completed my BE, Bachelor of Engineering, from Pune University. I started my first company was Sprylogic. Okay, it's in Mumbai. It's App Lab Limited sister company. I am very thankful to start my journey here because I got to learn a lot here. Okay, I was here as an embedded developer. My job here was like 70% firmware development and 30% embedded hardware development. Hardware development mostly design, like selection of controllers, selection of particular ICs, okay, designing those ICs, creating prototypes, and then do the actual code bring up and developing the application. See, you people might have seen the fuel dispenser, the petrol machine, whenever you go to fill the petrol. Okay, out of like I would say 100% of India, 40% of the dispenser, I can proudly say the software, the firmware and hardware designed by my team. Okay, which was in Sprylogic. Here it was a startup. Okay, it was like a 30-40 people team, and including everyone, like IT and everyone. So here I got to learn about leadership with the technical things also. So here I was like embedded developer, but as the team was small, I was also managing the client eventually. I worked here for almost 4 years. So there I learned to manage clients, manage a team, okay, setting up meetings with the technical experts out of my company. So very enriching experience. It's always good to start with a startup, my opinion. Okay, if you want to do a very good development career. Okay, because here you are, so there is no processes, you have to set processes, and very demanding, but definitely very enriching. 2014 I started as a freelancer. Why I started as a freelancer? Because I wanted to do something different things, not to just bog down by like one product or one project. Anyway, I was getting multiple projects at Spiralogic, but I wanted to try it on myself. So I started in 2014 as a freelancer. Eventually, I started Stuffbits LLP at that time. But yes, I was also consulting Spiralogic with their existing products. Here, I learned about as a freelancer how hard it is. Okay, running up a company, how hard it is, and getting projects was so difficult. Okay, so here again, my most of the job was now with designing hardware and developing embedded C software, plus again getting a clients, right? So I did this for 2 years, and then I figured out, okay, it's not a job of a one person to run a company. It takes a team. Okay, so in 2016, I joined John Deere India in Pune. That is the first time I actually worked in the embedded domain in automotive. Okay, and John Deere is mostly off-road company, so they do tractors, harvesters, planters, seeders. Here I was again embedded developer, but my major role was in firmware development, because if you go to the big companies, they have teams specifically for specific domain. Okay, so majorly I was working in a harvester domain and particular modules. So as the features are very big, I was working on specific modules of in this company. Here actually I got introduction with MATLAB. Most of the companies in the application layer, they do instead of embedded C, they do development in the MATLAB based like Simulink and Stateflow. So I was a model developer. Some part I was doing in C, embedded C. Then I learned about unit testing and hill testing, which like small companies, startup don't do. They don't have that money and infrastructure to do these things. Big companies definitely do. They have to do it like unit testing, hill testing, because they are too big to fail, right? So they don't want any bug to go to their customer. Okay, so they do rigorous testing, regression testing with startups. So that's why startups are lean and faster, because they don't invest a lot of time in testing. They invest a lot of time in development. Fail, develop, fail, develop. There is no particular process. But big companies, they have processes. So I can't go and do hardware development there. Okay, even I knew about something about that. So that is there. 2018, I moved to John Deere USA. My role also shifted from developer. I became a system engineer. So job of system engineer was to get the requirements, system requirements, okay, or marketing requirements about a feature. Take an example. If the marketing team tells you that I want a seat or a steering wheel, okay, which should have this kind of feature, this should buttons and everything, then my job was to convert those marketing requirement in system level requirement, and what are the inputs this system will get, okay, what the outputs will be, what different systems will be affected, because steering wheel we have button to turn on the music system, to control the volume, right? So now I got the holistic idea about how the system work. Before that, like in startup, I was working on a smaller embedded products. Okay, they did not have a distributed systems like automotive. So even there, I was doing some kind of system engineering that was not like big enough. When you move on to the very big systems like automotive, there are hundreds of controllers, hundreds of systems. So even you are a system engineer, you are not a system engineer for complete vehicle. You are a system engineer in for particular domain. So like in automotive, in on-road, we have body domain. Okay, we have a powertrain domain. Okay, so then there is a there are other domains you have to work about, right? So there is system engineer for per domain. I was system engineer for power domain. I was still doing some kind of MATLAB development, rare C, just to prove a concept or something. But it was mostly job to uh, create a flowcharts, create a block diagrams, write a requirement which the developer will know, understand, okay, in a technical language, figure out the corner cases in system design. Suppose that particular canvas does not come on time, or the value is corrupted, how the system should behave. Okay, those kind of decisions as a system engineer I used to make. Then there was another uh, part of my job. I think that is reuse. Okay, so now with the software being a bigger part of your system, right? Uh, Organizations understood that okay, reuse is a big part. Okay, because as I said, there are multiple teams who are working on a specific domain. Take an example: someone is working on a powertrain domain and someone is working on a body domain. Okay, but they are using the same below embedded system, same controllers. Okay, they are working on the same CAN module, same UDS layer. Okay, so in that case, before the reuse actually become part of a organization thinking, everyone was doing their own development, everyone was doing their own UDS development, everyone was doing their application development. So my job was to talk at the organization level, okay, or enterprise level, and then figure out which systems are study their systems, figure out which systems are common, and we can develop a common requirement and common software module, so that then the common team can then dispatch or deliver those systems to this particular domain teams and they can utilize it. It was actually very challenging role because each domain, okay, each platform had their own timelines. So somewhere we had to deliver based on their timeline. So someone wanted that particular module to be delivered in a week, and other platforms said like we need in 6 months. Okay, so it was very challenging to manage everyone's expectations. Okay, so as I said, 70% of my job role was a system level design. Okay, then again, when I came back to India in 21 after COVID, I restarted Stuffbits LLP. There I had some contacts. I was doing some kind of a freelancing. I started that again, and then I started building my team one at a time. So I got some on-road development projects. So I have not mentioned here, but when I was in India in John Deere, I had opportunity to work on AutoSAR. Okay, so if you don't know, AutoSAR is a kind of framework, OS framework specifically made for the automotive ECUs. Okay, it makes the life of automotive OEMs easier because now you have a common, as I said, and again, it's a reuse thing. So before AutoSAR, every OEM was developing their own OS stack like FreeRTOS or new. Uh, and they were developing their own stacks for UDS or other CAN stack or Ethernet stack. Uh, is my screen not visible? Your visible, sir. Okay. Okay. So everyone was doing their own stack development. Take an example. So if there's a company in US who is an automotive OEM, big automotive OEM, they don't do their own in-house development majorly. Okay, they find tier ones like Bosch and Continental to do their work. Bosch and Continental have similarly, those are tier ones, and they have multiple OEMs. Like a John Deere is the OEM, and then there is a Ford is OEM. Okay, and there is a Volkswagen as a OEM. They give their work to this particular tier ones. What used to happen before AutoSAR, that each OEM used to dictate that you need to use this OS, or we like John Deere had his own John Deere OS built upon John Deere system before they went into AutoSAR. So now the tier ones had to manage, even if they are delivering a seat architecture or seat ECU, okay, they had to design and develop and maintain different repository, different code for different OEMs. Okay, if you see the coding, if you see the project C project for any of the ECU, 50 to 60% is like a OS, right? And 40 to 50% is the actual application. Then OEMs figured out, okay, the OS is not the part which customer wants. What customer wants is the application part, the feature part. So why even to invest time and money in that? So they started this AutoSAR journey where all the OEMs came together. They formed the guidelines how the OS should be. Okay, what are the APIs and how that should look, and then they gave that like thousands of pages of specification to the tool developers like Victor GmbH from Germany, and they developed the OS, which now most of the uh, automotive makers use. So now what they do is when they like a Ford or John Deere, they go to Bosch and ask for a specific ECU, like a body domain ECU. They say use AutoSAR and then build our application. This is our system requirement. Okay, this application you want to develop, then develop. What happened with that is the development time become faster, right? Because now the tier ones did not have to develop their own OS. They had to purchase the OS, configure that OS, okay, and just build the application on top of that. If suppose tomorrow someone different OEM comes to them and they said, okay, we want similar application but a different features, slightly different features, what they can do, keep the OS same, just configure the application to work for this particular way. So development time become faster, less bugs because now OS has been tested by multiple OEMs. Okay, so less bugs. So that is the reuse is a big part of industry now. Okay, because OEMs want to reduce the cost. Okay, on infra part because OS is the infra part, not the user visible part, right? So yes, so I started yes AutoSAR. I learned about AutoSAR. I worked in AutoSAR. Then when I started my journey again in Stuffbits, I got the project in AutoSAR where we configured the OS for some of the tier ones. So and then deliver those projects. Okay. And 2025, we converted into the private limited with collaboration with PDSL. Now we provide 360-degree solutions for embedded. So we do hardware, we do firmware, we do manufacturing, we do prototyping. Okay, so I'll talk about that later. Now my job is like even as a founder, my mostly job is engineer. Okay, I have to do everything. So there are multiple projects. Now we have a team of 24 people. Okay, so in 21 I had one person, two person. Now I have 24 people, and we are going faster. Why 24? Because mostly I do in-house projects, and the other thing is I hire people with great caliber. Okay, it's just not a head count. Okay, they have to actually work on. Like me, they had to work on from hardware to software. So whenever someone joins here, he does not join as a firmware engineer. He does not join as a hardware engineer. He, as a fresher mostly, he joins as an embedded engineer. So he has to, for a couple of years, he has to do everything. And then he can decide his journey if he wants to go into hardware or he wants to go into firmware. Okay. So right now I do embedded C development. I do hardware design. I don't do hardware development now, but mostly hardware design, architecture, and reviews I do. I learn app development as a need, so I know that. I do system engineering for most of the end-to-end product development projects we get, not the projects where we just have to do some firmware development part. But if some customer comes to us that, okay, Stuffbits, Kumar, we want to do this product, hardware, firmware, and everything. So in that case, I do complete system engineering. I do project management for some of the companies. Okay, just manage their projects. What is happening, why is that happening, and how they can smoothly deliver the project. We do DevOps. DevOps is the big thing now with the AI coming in. DevOps is going to be a big thing. So we support some companies, mid-scale or scale companies, to integrate or start their journey with DevOps, like pipelines and then Git and project management all integrated together. So less bugs and faster development. Okay. I highlighted the AI part. So from last 2 years, or majorly I would say 1 year, as you might have seen the rise of AI, and we are now majorly doing our development, firmware development mostly, and software development using AI tools. So that does not mean that you as a fresher should start it. I'll discourage it. Okay, definitely use AI, but do some hands-on, write your own code, because AI is just an assistant to you. It does not know everything. Okay, so yes, and I do company operations. What I'm currently doing is that will give you exactly how my day goes. So I'm analyzing erratas for NXP S32 S32 K3 series controllers and providing the code fixes for that. So if you don't know what the errata is, I'll just explain in a brief. Okay. So errata is, so take an example, NXP has manufactured some or they're giving some microcontroller to you. Okay, particularly S32K3 series. Those controllers, if you look at their data sheets, okay, or reference manuals, those are very complex things. Okay, uh, those are software written in silicon, right? So similarly, you do unit testing for your software firmware. They have to do their hardware testing or microcontroller silicon level testing and test all the permutation combination. The problem is there are infinite number of permutation combination. So what these companies do, they test 95% of cases, use cases, like their module use case, how the flash will be used, how the timer will be used. So they cover 95% of use cases of their particular chip. Okay, if that is satisfied, then they release it. On the field, what happens, some particular OEM or some particular users configure those peripherals like flash peripheral and some other peripheral in a way that particular silicon manufacturer has not tested. Okay, like the flash is accessed by three parallel masters like ALU, HSC, and other like DMA. In that case, the silicon vendor never thought someone will use it. So someone uses it, it does not work, or it has works but is not work it does not work perfectly, it gives you some error. So that user reports that issue back to the silicon manufacturer like NXP, that I configured this way but it's not working. So on even parallelly, NXP team or the silicon manufacturer, they are also doing their corner case test cases. If they figure out, what they do is they will release a errata document. Okay, so if I can show you that errata document, I have it open. So yeah, it looks like that. Okay, so what particular issue is, how that issue will come, and how you can fix it. Okay, or how you can have a workaround related to that. Then they release it. Okay, they fix it in next batch of their silicon, like after 2 years, 3 years, they revise their silicon. Okay, and then they release the new silicon chip, like our firmware, like on a mobile you get a OS update for your mobile, right? Similarly, they also release their silicon update for that particular microcontroller. But till that time, whoever has used that particular version which has bug, they have to live with that issue. Okay, so my job is right now to figure out what the errors are. Are those applicable for that particular application we are using? Are we configuring that module in a such a way that this errata will be applicable for me? If yes, how can I give a code fix? Like how can I give a solution in a C which will uh, fix this issue for the OEM? Okay, to do that, to do this analysis, to give a fix, you need to have very low level understanding of how microcontrollers are working. Okay, so yes, I'm showing the slide if someone is asking. Okay, so right. Uh, and So yes, so my experience with my initial startup company where I was embedded developer, I was choosing the controllers. I was writing a device drivers for those, low level drivers for those, and designing hardware for those. So that experience helped me with this. Okay. Uh, then I'm currently also managing a team who is developing a secure bootloader for again a US based automotive company. If you don't know, you should know what the bootloader is. Okay, this is the application which runs before your application and which is responsible for programming your application on top of the old application, right? If you want to provide a bug fix. So like a mobile, you get a notification that the new application is available. You do want to install. So bootloader is the same thing, which is programmed into your microcontroller and which runs before your application runs and figure out if there is a new, someone is trying to program a new application, and then it programs a new application on the currently running application. Why secure everything? You will figure out when you work on it. So right now I'm working on a team who is developing bootloader for multiple platforms. NXP is there, STM also is there. Okay, here my experience in low level definitely helped me, but as a system engineer, how to look the things on from the top actually helping me. Then there is third thing I'm actually doing is right now I'm also developing a secure bootloader for Indian automotive. Here my job is to actually write this complete. This is a product we are developing. It's not just a firmware. It's a hardware and software product, a firmware product. So my job is to design a complete system architecture, like how the bootloader will work, what kind of communication protocols we need, how that transition will happen. Okay, so I'll just show you that how the system requirement look like. Okay, just give it a minute. There is a problem with this thing. If I get it working in a minute, then I'll show it. I'll show it now. Let me know it's visible. Okay, yes. So this is how the system requirement look like. You have documentation work. So majorly you don't write code here. You design, you draw flow charts, okay, and how those will work, how the system will interact with the external system. Okay, so that is how the what are the corner cases which happen. Like if you say this is a UDS programming flow for your bootloader for your application, so what are the transitions and where it can fail. So all those decisions and architecture decisions we have to make. And once this is done, we deliver it to the software team, and the software team then start developing on top of it. Okay, and then there is the interaction between system engineer and software developer or firmware development. Or if they have questions, I resolve those. Okay, so yeah, this is what exactly I'm working in, and this is what my total experience and how I reached here. Then let's move to the next point. So I'll talk about Stuffbits now, exactly what we do. Okay, it will give an idea about what career paths you can choose. Okay, so we do design and development. So we do both hardware design and firmware design development. We do a low-level driver development for USB, Ethernet, CAN, GSM. So like touch screens and everything. Okay, so we do like very low-level development. We have worked on different platforms like for automotive. I would say Infineon. Mostly in John Deere, I have worked on Infineon. Then Renesas, I work for fuel dispenser applications. Then currently we are majorly working now. Major focus of now is into NXP. I have seen a lot of companies now moving to NXP for automotive products or development. Then for general embedded, we use STM32, ESP32, TI. Microchip is not there. It's dead I haven't seen some majorly in industry people other than power industry people using Microsoft. Okay, for GSM cocktail modules and those. We do communication protocol for automotive industrial. It's Modbus. Okay, and Gemini 3 and somewhere, but it's a mostly automotive protocol. Then UDS, ISO 14229. UDS is for diagnostic purpose of a vehicle. Uh, then CAN, LIN. For networking, MQTT, TCP/IP, Bluetooth. So those protocols we develop here, or application based on these protocols we develop here. Then application development, like a top level development, TFT UI designs, then application specific to the customer. Uh, then if you are in like some wants AutoSAR, then we have for AutoSAR we have there are a lot of tools. You don't have to do a lot of coding, I would say, in configuration. There are tools provided by Vector. You need to learn about those tools. But my experience is, I have seen a lot of people directly starting their journey in AutoSAR, where they had to just configure the tool to generate a code. Okay, what my experience is, the people who have started their journey from writing low-level driver development, C coding, for them adopting AutoSAR was very easy because they knew what is actually happening in backend. Okay, how the tool is generating that codes. Okay, uh, what the other people who started their journey uh, with the AutoSAR as a configuration tool, they faced a lot of issues because they were not knowing exactly what is happening downstairs. How you configure the CAN driver, what are the mailboxes, okay, how to apply filter, how to apply acceptance filter, acceptance register, why CAN is a differential communication like RS485, why is sing not a duplex communication. Okay, so I would suggest whoever wants to have a very good journey in their development as an embedded product developer, start with the small. Okay, then we do hardware development. We do feasibility for hardware. We do automotive. So for automotive, AEC Q100 200 is the compliance. We do BOM cost analysis, bill of material analysis, optimization, schematics, 4-layer, 4-layer schematics, and lot of like EMI, EMC compliances. I have personally designed 4-layer board last year. There is a need, and so lot of hardware development we do for the product development companies which come. Mostly it's the industrial or embedded products we do in hardware and some automotive. Then we do prototyping. So whenever we do hardware development or product development, we have to do 5-10 batch of prototyping, testing. So you have to do design verification, engineering validation, a lot of iterative testing. Okay, so that we do. And then we do a production. So whatever we design, most of our clients which are from the industrial domain, they come back to us and they say, okay, Stuffbits, can you do a production for us, also for us? So we do production. We have a production unit. Currently, I manage it. So we do like 1,000, 2,000 piece production, assembly, testing, supply chain management. Okay, end of line. So all of those things we do in Stuffbits. Okay. So let's move on to the next point. Yes, I have copied this from DIY slide deck. Okay, I found it interesting. Okay, when you say talent gap in embedded EV systems, I would say I will remove the EV and I would say talent gap in embedded systems. People say, okay, a basic problem, engineers is fundamental coding skills. Okay, 75, I'll not agree. I'll say 5. Because we take interviews, we need people. I see, I don't know why, but even my experience is 15 years. After even 15 years, I don't see people who have a good programming, basic programming or microcontroller understanding. If I ask someone to tell me about how the timer works, I don't get the answers. What people or students are majorly focusing on, if and specifically embedded, I would say embedded product development, they're focusing on application layer. I would say just go down, start your journey with the driver layer, start to understand the microcontrollers, how that works, because even AI can't replace if you have a your fundamentals are strong. Okay, so please start with the very basic. Start toggling a pin, see how the GPIO is configured, how the hardware of GPIO is, why they are why they have open drain configuration for I2C pin. Okay, why not have an internal pull up on the I2C pin? Okay, so there are very small things which are very important, and we are not actually going through that level. Okay, we are jumping a ship and we are jumping directly to the application layer. Don't do that. Okay, application is not that complex. Okay, it is complex, but at your level you have to figure out the lower levels. Okay, so basic programming 75%, I don't agree, I would say 5%. Okay, based on the hundreds of interviews they are taking. Okay, so and how to do that? Get a and You people are very fortunate, because now, like 15 years ago, I did not have Robo.in. I did not have a supply chain management. We did not have a development boards. We did not have very good internet community to help you. What I would suggest, get a development board, start with a one module, start how to configure a clock module. Okay, what the FLL is, what the PLL is, what the high speed external clock is, what the HSE is, speed internal. Okay, uh, how how to select the clocks. Okay, what are the different modules which are clocked by internal crystal or external crystal? So that is very important. So start with low level. Okay, then move on to timer. Okay, how to configure a timer, how that interrupts work. Okay, how to configure an interrupt. Okay, why interrupt has to be the interrupt routine has to be very short. Okay, uh, and then toggle a pin in the timer interrupt. Okay, I even still today, when I get a new board, first thing I do is toggle a LED, connect a LED or some IO, and then the toggle a pin in the timer interrupt. Okay, even if I do like a very big uh, automotive ECU project, the first thing we do is toggle a pin. Okay, so very important. Okay, to go back to the basics and do all these activities. Once you do activities, it will be slower start. It will take a year or two for you to do it, and but it will be a lifetime thing for you. Okay, system level, yes, definitely. You have to have that knowledge to understand how the things work. Okay, but that is required, but not immediate. Okay, how the EV works, how the systems need, but start your career at a basic fundamental layer. Okay, and then jump into the big things. Okay, and yes, the embedded, it's hard. Okay, but now with advancement of AI and advancement of the systems, okay, embedded is a big thing. I'll show you why. I have an example. So why embedded in EV or even automotive, or I would say any product now? They are more becoming more embedded firmware. Okay, eventually the gap of embedded and IT will also reduce. Okay, so those will become very connected, and it's happening with IoT. But let's start with this. So I copied this statement from somewhere. In 2005, the car had 10 million lines of code. Now in 2025, EV has, or even car, I would say, ICE car. Okay, internal combustion engine car. Only engine is, I think, would be mechanical. Most of the things, transmission is mechanical, but most of the things are run by embedded software. Okay. Uh, I'll tell you an example. So when I joined John Deere, before I joined John Deere, they had only 200 or 300, even less than that, people who are in embedded in India. Okay, in Pune. When I left, okay, it was like 1,500 people. Okay, in 4 years. They stopped hiring in mechanical. and they started hiring in embedded majorly. Now, when I left, the trend has also changed. Now they're hiring majorly in IT also. Okay, so secure system, IoT, backend system, DevOps. So the types had changed. Okay, it was a funny thing when I used to tell my immediate relatives or people like I joined John Deere. At that time, their perception was I was doing something in factory and mechanical thing. Okay, I'm working in a factory or a shop floor, because no one envisioned that the tractor has more lines of code, and there are like a team of 60 people in India and 30 people in US who are just working on a firmware part of a tractor. Okay, so changing that perspective, it takes time, but people are realizing okay, an embedded is a big thing now. Okay, uh, let's jump on to the next point. Okay, so I'll now take more time in this particular thing. Uh, that is what layers and how those are embedded and what layers are actually utilized, which are embedded in which are in EV or automotive. Okay, take an example. So layer one, control layer. Okay, so if I get a chance, I'll also draw to help you understand. Okay, so when you say motor control, BMS algorithm, DC-DC control, inverter logic. So motor control, if you think about EV, you will say motor control is mostly controlling the motors or four wheels of the EV, right? No. Okay. Motor is now even motor control is needed. So as I showed you, there is I told you about this, right? So we are developing this, designing a secure board architecture for Indian automotive. So it's not a EV project; it's a ICE project, and it's off-road trucks we are developing the software for. But it's very secure, and it's a motor controller. Okay, so for secure boot loader we are developing, it's for a motor control. So which motor? So in vehicle you have a oil motor to control oil injection. You have motor to control the coolant. You have motor to control the wiper fluid. Okay, you have motor to control. So you have this fan of AC. Okay, HVAC. We call it HVAC. So, and then in advanced vehicle, you have a flap to control where the air is flowing, right? In advanced vehicle, that is also controlled by the internal motor, okay, with a touch of a button. Then you have external mirrors which are controlled by motor, right? You can make them go outside, they make them turn inside, right? So the motor control is a big part, and definitely the motor control at the actual wheels control is very also a very big part. Uh, so these are like BLDC motors. The controlling a motor, okay, it's not just a firmware developer job. So I haven't seen anyone who has started their career in automotive become a motor control expert. Most of these people who are in motor control design, hardware plus firmware, come from non-automotive field. They started their career in some projects which are non-automotive. They learned about control algorithms of motor, and then they shifted career in automotive, similar to how I did it. Okay, so to do this, you need very good understanding of algorithms, hardware layer, how to control the MOSFETs. Because when you want to control the motor, you have to control the MOSFETs. Okay, so I've seen people who worked in UPS development actually jump into the motor control. Thanks. Okay, BMS again, battery management, very complicated thing. Okay, you need I would say PhD person to do this, because there are algorithms you have to configure, because individual cell has its own personality. Okay, so map that to control that to we have done some battery related projects, but we figured out it takes a lot of talent and energy to work in BMS. So there are companies who are just expert in BMS. Okay, so even OEMs don't manufacture their battery packs. They get it from some tier ones who are expert in the battery management systems. Then DC-DC control, because you are driving some actuators, you are driving a motor, you are driving heat systems. Okay, so you have to convert like 12 volt DC to 24 volt DC. Okay, boost 12 volt DC to 5 volt DC, buck to provide the voltage to your microcontroller. Okay, then inverter logic. Okay, so again, in to convert your AC 12 volt to 24 or AC DC 24 volt to AC voltage, or in charger algorithm converting your AC input AC to DC. Okay, fast charger and those. So even charger is a very big, I would say, system. There are a lot of protocols. There are there is a lot of hardware. There is a lot of firmware. There is lot of safety systems you have to configure, right? So that is there. So for you, you need a very good hardware development or design experience. You need very good firmware design experience. Even the firmware engineer needs to know hardware, because without knowing him hardware, how is going to create a PWM, how is going to control the MOSFETs, how does he know at what time how to trigger that MOSFET? So a lot of hardware interfacing you need to know, right? Then you need to know model-based development, because you have to predict or create simulations in Simulink, right? Then communication layer. Okay, this is where we majorly work. Okay, we layer one we have very less, as a Stuffbits we have very less experience. Layer two and layer three where we have majority of development experience. So we do CAN driver development, because most of the all the ECUs on vehicle are talking on CAN. Then came the CAN FD. CAN FD is just a CAN with possibility to send more data, 64 bytes at a time. So CAN FD is also a new thing. We are actually taking CAN FD from automotive into industrial environment. So a couple of projects we have moved into the canopy. Then Ethernet now, as the data is becoming big and faster, so you need higher throughput on the communication channel, because ECUs needs to talk to each other on a higher rate. So now we are doing some projects for US automotive where the controller does not have CAN, they have Ethernet, automotive Ethernet, two-wire Ethernet. Okay. Uh, you can talk like 100 Mbps on that, because CAN is 1 Mbps, CAN FD is I think 8 Mbps or something. Ethernet is 100 Mbps. Then you need to diagnose issues on the vehicle, because you don't have a direct access to your ECU. ECU is like embedded into your chassis or mechanical thing. So if you want to diagnose something, you have to send commands on the communication channel, like Ethernet or CAN, and then the particular ECU will respond. So UDS, Unified Diagnostic Services, is a big part of software part of automotive industry. This is ISO 14229 standard. ISO has defined for this one. So similarly, DIYg, diagnostic over IP. So diagnostic over CAN and diagnostic over IP. Diagnostic IP is becoming a big thing. Okay, OT updates. So as cars are becoming intelligent, more and more code. So that means more and more bugs. Okay, as I said, with the silicon manufacturer, they test 90%, 95% of use cases. They leave out 5% because they have to ship the product. Similarly, automotive industry, there are hundreds of ECUs. They can't test every corner case. They test 95%, ship the product with the. So they categorize issues like critical, major, minor, and good to or enhancement. Okay, so till the major issue, they fix everything. Minor and like enhancement, they keep it there. They release the product. Okay, if on the field and they test it parallelly. If they find the bugs, they don't release immediately. What they do is they create a package for 6 months, like your mobile phone updates. Mobile phone updates come once in a 6 months or a year. Similarly, they create a package, and then they send it over the network to your vehicle. Now vehicles are connected to network now, and then the gateway ECU will take all the packaged software, and then on UDS it will program each ECU while your vehicle is in the parking, right? Because even if you turn out the vehicle, ECUs are still powered, right? So OT updates are there. You need to learn about vehicle networks, the CAN network, the Ethernet network, the J1939 protocol. So J1939 protocol is specifically made for the automotive industry, off-road automotive industry. So LIN, right? For this, you need to have a very good understanding of firmware development, low-level development, because you're driving a CAN, you're driving Ethernet, uh, LIN, right? Then hardware design, if it's good to have hardware design, and not must, because you should know how the CAN messages are flowing, how the Ethernet messages are flowing. If there is a bug, how you can solder, desolder, and fix it. Then safety and cybersecurity layer. So secure boot, as I said before, your application start, the secure boot will take up, figure out everything is okay, application is authenticated, then only it will jump. For that, last 6 months, Stuffbits, we learned a lot of about security, a lot about how to implement it. Security is now big part of not only automotive, and it's also non-automotive. So there is a big chance again to go into security, but again, I'll recommend start from low.
Sir,
Understand how.
I have one question now.
Please
If
go ahead.
very good evening. If
Mhm. I'm losing you. I'm not getting.
ITI student have either mechanical, they have idea how they can navigate.
ITI holder. Okay, as I
Hello.
said, now
Yeah.
you can just take buy any STM module online. Okay, go on YouTube, figure out. There are a lot of projects
Hmm?
people have done as open source. Okay, and start following their steps. How they did it. Right, there are a lot of material on tutorials on how you should start with that particular board. Okay, it will take time. I'm not saying it's like a in month, 1 month you'll be expert. It's very painstaking journey. It will take a year, but if you are dedicated enough, okay, and you're ready to ask for help and learn from yourself, definitely it's not that a big deal right now. Okay, but yeah, you start with first step: buy a module, buy a development board, and then start toggling the LED, start developing products, be a freelancer. I would say that I'll recommend. There are a lot of small scale industries in India where they are not getting very good product development help. Okay, because big industry or even my company can't sustain helping them. So what I'll suggest, go to them, uh, do a project for very low cost, and then you will learn about it. Okay, that's the optimum journey I would tell you if you want to start an embedded field. Okay, have I answered your question?
Yeah, sir. Sir, I have that only question, but as a freelancer, how to become in this sector?
How to become freelancer?
Yeah, in embedded, if he's coming from a low background also.
Okay. You go to LinkedIn, post your that I am ready to do freelancing. Okay, but before going to freelancing,
Okay.
also start developing some hobby projects. That will help to like market yourself in the industry. That okay, I have done 3 projects like this, right? Relay control, or LED control, or motor control, right? It will take like 6 months for you to build your own portfolio, okay, and then publish online, and then someone will come back to you and then tell you, okay, I want this. Go to industry, small industry area, talk to people. That is how I started. Okay.
Got your point, sir. Thank you.
Okay. Yeah, then I'll make it quick now, because this is where like security ISO 26262 is like a FUSA, functional safety, because people are, functional safety is not for satellites, but functional safety is for car. Why? Because satellites, there is no person who is sitting in it, but vehicle, there is a person sitting in it, or it, even autonomous vehicle, it is running on a road, so there is a safety issue for people. So when we have designed one system for satellite, it was so simple because there was no function safety requirements. But automotive, you have to take like a small piece of code, and if that a functional safety issue, it takes a lot of time to develop that because you have to think about a lot of things. Okay, even from controller selection. So if you want to have a ECU which is like a BMS or transmission issue, controller has to be selected which is functional safety rated, ACD rated, ACB rated. Okay, so and the software has to be also rated. So this is again a completely different. So you can make your career in this FUSA again, but to go here, I would say start from the basics, jump to this, and then decide which field you want to go or build your career into. Okay, but don't directly try to say I'll be a functional safety engineer. You'll not be good functional safety engineer. I'll tell you that. If you want to do, I'll be secure or security engineer kind of a thing, right? Embedded security, expert in embedded security. And you say, tomorrow I'm as a fresher, I have to jump into this. Please don't do that. You will not be good. I have seen people who jumped into that, failed miserably. Okay. So
Sir, side by side, we can do internship also, no, based on
yeah, you can start internship.
this.
No one is stopping you. Again, that's another path you can take. Great. Yeah, that's, and then I'll not go to this driver BLL. It's a very, you can learn by yourself. You can just take screenshot, but of this last layer four, but I'll say start from this. Okay, I think I'll just jump into actually what we do. So these are products we do just to give an idea. So complete industrial automation, micro-based controller based 4.3 touchscreen we have developed. Okay, it's connected to the internet. It has Ethernet, is at Wi-Fi. Okay, it has MQTT, and we have a cloud-based solution. This is what we have for 7-inch LCD, used developed for specifically for UPS, industrial UPS industry. It has Ethernet, CAN, and everything. So even it is not an automotive solution, but it has all the modules which are needed for automotive. It is, we are using automotive control for this, right? It has CAN, it has Ethernet, okay, a lot of things. This is a IoT based, Bluetooth based. It's a app is designed by us and everything. There's a PLC. This is again Wi-Fi based controller gateway. The front end is designed by us. This is for automotive industry, but not exactly automotive, which goes into vehicles. So we designed this for John Deere for their factory automation. Okay, it's a wireless LoRa controller. This is your Paytm machine. Okay, the sound box. This is pharmaceutical products. This is the fuel dispenser. Again, a lot of technology which is used in automotive is being used. So it has a secure bootloader, it has CAN, it has Ethernet. Okay, so a lot of things which we are actually using in automotive, we actually learned from developing this product. This is a USB to CAN converter. This is our own product. It's a touchscreen based converter, which is you can connect to vehicle and all the information you can get it from vehicle. Yeah, and these are like the firmware development. As I said, we do a lot of secure bootloader, DIY based, CAN based. Okay, so major part was the security. Okay, how to use the hardware security model from microcontroller, how to configure that, how someone cannot break it. So design a firmware based on that. We did something ECU development for the backhoe or the JCB, I would say, in simple Indian language. Then we did the harvester. So when I left John Deere, I joined it again as a consultant with my team to deliver one product for them. You might have seen WinFast coming in India. Okay, so for WinFast, my team has done the factory level diagnostics testing. So we went to Vietnam in the factory floor, and we connected the tools to the vehicle and did all the diagnostic, because all the ECUs are coming for tier ones. Okay, the WinFast team integrated those test, but to test they wanted support. So we went there. It was a very new experience for me also because I never did vehicle testing. Went there, learned about it in like a week with other people, and then delivered this work in 6 months. So here the vehicle is on the shop floor. You get the vehicle, you connect a CAN logger, you run tests, you figure out what the issues are, and then you report those issues back to the tier ones that okay, in your issue this is the issue, you have to fix this. So that validation for WinFast we are done. AutoSAR, as I said, we have worked on AutoSAR integration, and we do product manufacturing, small batch product manufacturing. Right, I think that's it from my side. I have taken a lot of time, but yeah, I think we can, if you have, I'm open for questions. I'll just open this guy.
Yeah. So hi, Kumar. This is Asha here.
Yes. Yes.
I'm from IT background. I'm a software architect in one of the big MNC. Work on the Android products. So
Perfect.
Android applications with several, like, I mean, so from banking to IoT application to e-commerce. So, I mean, during the session, right, I mean, you mentioned about the AutoSAR and the collaboration of the all other companies to have that specific thing as in kind of an operating system of.
Right.
Okay, but like, I mean, recently, if you have heard about, right, I mean, Mercedes-Benz has come up with their MB-OS. So
Yes.
is the MB-OS is based out of AutoSAR, or is it the explicit to only MB, or is that the thing like under the, I mean, MB-OS is on top of the AutoSAR? Is that the correct understanding? If you
Okay.
just share some detail if you know.
Sure. Thanks. I'll tell you. I don't know about what they are doing with MBOS, but I'll tell you that what I know about and my experience with AutoSAR is AutoSAR is failing.
Okay.
Because my experience, John Deere, we started AutoSAR, but eventually when I left in 21, John Deere went stopped using AutoSAR and went back to their own JDOS or John Deere OS. They converted to 32-bit OS, and I'm working with the US based automotive. Tesla does not have AutoSAR. Okay, they have their own system. The other big automotive, they are using Zyper Artos instead of AutoSAR. Okay, and they're developing their own kind of system. Adaptive AutoSAR was going to be a big thing, but I haven't heard about it in like the last 2 years. Okay, AutoSAR also we have stopped getting work on AutoSAR from last 2 years. Okay, a lot of so AutoSAR is very specific to, I would say, Europe, because it started in Europe. Europe, the mindset is like very process oriented. Okay, so they are slower. They are innovative, but they are slower. Europe, US, I haven't seen a lot of companies now sticking with AutoSAR. China, no AutoSAR. India, definitely AutoSAR. Japan, India, because they follow mostly European market. Japan, no AutoSAR. South Korea, no AutoSAR.
Sir, Mitsubishi Electric also trying.
Sorry. Can you repeat that? Okay. Sorry. So, yeah. Okay. I don't know about Mitsubishi, but like whatever companies I have worked, and I know the reason why AutoSAR actually failed in John Deere and why it's failing in some other companies. The problem is the monopoly of some of the tool manufacturers which are AutoSAR, which are delivering AutoSAR. The cost is too high. Okay, and the promise that the development will be faster is not sticking true. Okay, it's definitely faster than the if you should do from scratch, but definitely it's not that fast based on if you consider the cost, upfront cost, because the tooling, everything is the license based, everything is cost. So there are a lot of companies we are going back, because the problem was when automotive thought about moving to AutoSAR, they said we'll move every ECU to AutoSAR. You can't move every ECU to AutoSAR because there are very small ECUs which like 4 pins. I had a very funny requirement where one company asked me that, Kumar, we want to do AutoSAR with this particular ECU. I said, okay, perfect. What is the interface? CAN, Ethernet? Say they don't know. They said there is no communication protocol. Okay, fine. Why then? How the ECU will get commands? They said it's just a PWM coming from another ECU, and then you have to convert that PWM to some IOs, control the IOs. I said, why do you need AutoSAR for that? Okay, because it's a funny thing. But say no, the OEM is asking for AutoSAR, and then when we calculate the budget, it was going into crores, and then they stopped the project. They don't know. They said we are not going to go ahead with this project. It's a very simple issue, right? So that's why I see. I don't know current market because we are not getting any work in AutoSAR, but that is what I have a feeling with AutoSAR. Have I answered your question?
Yeah, because I mean the reason of this question is like most see, I mean everywhere like I mean AutoSAR is being actually been taught because to be moved towards to implement the ADAS levels, right?
Mm-hmm.
So if I mean if the standardization is not there, I mean I know it is okay because it's every manufacturer has its own uniqueness to it. They have their own OGs. But yeah, I mean then like I mean to even though if you learn all the common things, right? Wouldn't it be difficult to crack into those companies because you don't know what are their architecture, their systems and all. So based on that, I had asked this question. You have to do the ADAS programming with a machine learning and do the predictive analysis, right? So there, like I mean, things get changed, right?
Correct.
So that's what the intention.
Perfect. You brought the right point. So at the AutoSAR is good on some domains of your EV or automotive vehicle. It's not good for everything, like a smaller controllers, okay, or control like a motor controllers. I have seen major part of that motor controllers. The drivers they write a CDD, so they bypass all the AutoSAR. They directly go and write all the logic in their custom device drivers. So which like defeats the purpose of using AutoSAR. So definitely AutoSAR has its own advantages, like as I said, UDS, you get the free stack, tested stack, you get the OS which is tested, you get the diagnostic which is tested, right? But definitely it has its weights also. Yeah, thanks for this question.
Sure.
Yeah. Anything else?
Sir, I have one question. Good evening.
Yeah.
Is it hello?
Yeah, I'm losing your voice. Can you repeat?
Is it audible now?
Yes, right now.
I have one question on the slide which you have shown. You said your company has developed one product called CAN to USB. Can you can you expand what is the features? Actually, we are looking for one converter. Site in our laboratory.
Okay, I think this one, right?
Yes, sir.
Okay, so we have developed this project with the collaboration of VDSL. So this is, I don't know if you have used Victor tools, Victor CANbox or PCAN. Okay, so they are also there. Victor is big in this particular domain. Most of the automotive use Victor thing. So we have on a similar line, we have developed this CAN, USB to CAN logger, I would say. This guy also works in standalone mode. Okay, so it has a touchscreen. You can configure CAN channels. So it has 4 CAN channels, 2 link channels, and 1 Ethernet. Okay, and you can connect to your PC. You can see all the CAN messages coming. You can transmit, create CAN messages and transmit, or you can also configure here and all the CAN logs from your ECU will be stored here. You can replay logs on a vehicle. Okay, you can do UDS diagnostics, basic diagnostic. You can send tester present. You can send some DIDs, those kind of things. So yeah, that is the product. It's still in R&D. We have sent this product for testing to Jaguar, Land Rover, and Ford and other companies. So it's currently being tested.
Yeah, we have vector products hardware in our laboratory and from education institution. Actually, we need some such a converter. Actually, can we buy like 1-2 quantity, or still the product is in?
You can, if you want a basic. Yeah, it's still in like we are adding features to it, but basic canned logger and canned tool is, as I said, we are also sending to some OEMs, so it's working.
Right. How to do that? Any contact details so that we'll approach you after the.
You can search me on LinkedIn. Okay,
right.
You can connect. We can have discussion further.
Right. Thank you.
Okay, can you hear me? I have a question. All right. So I'm new to the EV industry. I'm just getting a role to be an EV technician. And the little few weeks down the line, beginning to develop interest in embedded systems, and I have no knowledge about it. But my experience with the little troubleshooting we do is showing me a gap in knowledge. So I want to ask, what would be your recommended pathway, looking at the fields in which I am in now?
Okay, so summarize your question. You are EV technician, right?
Yes.
Okay, and you want to move into the embedded development world, correct?
Yes.
Okay.
Yes.
Yes, perfect. Okay, so to answer that, as I already answered, there is no easy path. Okay, so it's very difficult, I would say, specifically embedded, because it's related to hardware. And you have to debug, you have to even to install the drivers, it's very difficult on your PC first time you're developing. But it's becoming easier now. What you can do is you get a development board. So there are a lot of ST microcontroller development boards available, very low cost. Okay, you take one, search on a tutorial for those particular development boards. Why I'm talking about STM? Because STM has very good tutorials online on YouTube. So go there, okay, and then they will like tutorial by video, they will tell how to install a software on your laptop, how to connect the board, and how to write your first code to blink LED. Okay, start from there. Once you do that, okay, you try to do your own. You try to play with. I'll give an example. When I started my career as a first, out of college, I did not know anything, right? Like 4 years college, I enjoyed the life. Then, but I wanted to be an embedded engineer like you wanted to be. First day, I got one module, USB module. My team lead gave me. It has just a one LED on it, very small module, and he just showed me how to install the software, the IDE, and then how to start with the example code. There was a small LED program and to blink LED. For 2 days, I blink that LED in 100 different manners. Okay, delay based, timer based, button based. Okay, and I was playing with the LED. I configured every module allowed, and then later on UART, I send a command to turn on the LED. Just with the LED, I learned a lot about embedded system, lot about controller. Okay, so I would say start there. Okay, it's the optimum path you can learn embedded system. Have I answered your question?
Yeah, thank you. And I think to push it forward, I would connect with you on LinkedIn and see how we can have a conversation if I need guidance as I move forward. Thank you.
Sure. Thank you. Any other questions?
I have.
Okay.
Suppose if one wants to get involved with embedded system research,
Mm-hmm.
what would be your advice? Like, where can I start from? What, papers can I read?
Research means exactly what you want to do as a research.
Yes, but what would be like the fundamentals, for example,
Okay.
because I'm sure there's where you need to start from. There's material that you need to read. There's sort
Okay.
of certain basic knowledge that you need to have.
Okay, so if you want like a development, again, like you want to jump into embedded development and next is research, start with the reference manuals of a products. Okay, reference manuals of a microcontrollers. Okay, a lot of information there. I'll show you. So yes, so I actually even today I go to reference manuals and then I study this diagrams. Very informative. Most of the people don't actually go there and study this. Okay, so reference manual is like how this particular peripherals are connected, how the flash is connected to your ALU, why there is a I catch, why there is a D catch, how the database and how the data bus like bus arbitrator is there. So a lot of that information available online. You just have to go there and research. With the AI, I would say I do lot. I don't use Google now. I use AI to ask my questions. It's my research helper, I would say. I ask a lot of questions. I cross question the tool. I do a lot of research with the AI. I would say that's actually a game changer. I'm 10 times more productive using AI tools. That does not mean I directly blindly accept what it says. Even with this, as I said, I use the see the diagram. Actually, the AI tool showed me something. This is how it works. I went, I saw the diagram, I cross-questioned it, and the AI tool then apologized and said, "Okay, my understanding was wrong." So that is how you can even do embedded research, I would say. Sorry, I'm not sure if I answered your question or not.
Yeah, at least you have given me a clue of where to start from.
Okay, perfect.
Yeah, your advice is worth it. Thank you.
Thanks. Sure. Okay, any more questions?
Sir,
Mhm.
I have a question.
Mhm.
And so, and for model-based development, we may use the MATLAB Simulink for hill, sill, and mill develop and testing. And for Vision, we may use for the for software development and testing.
Mhm.
So, apart these are the two halves of the automotive vehicle. So, apart from the simulating and developing in these platforms, is is there anything else to learn as a beginner, as a fresher?
In a testing environment, you're saying, or in a model-based development?
Yeah, in both.
Okay, model-based, definitely there is a lot. I learned model-based development on the roll, on the job. I did not have formal training. I learned model-based development and the quality model-based development by looking at the models the other people had developed, learning about them. It's very good, I would say, tool to do coding. Okay, very interactive. We did mill. Definitely, I would say mill is a very good tool to test your models. Okay, but I don't know like what I can tell you in model, because there are a lot of libraries and lot of different ways you can develop a same module. Some people do Simulink, and same model can be developed using a flowchart, right? Uh, there has to be some rules, definitely, but you can do that. You can, I would say, if you want to go like a product development or like move on to this kind of a thing, I would suggest learning C. My personal experience, if you know C in depth, you can learn any damn language in the world. Okay, that because C tells you how things actually work on the on the platform level, on the controller level. Okay, if you learn C, because anyway, if you do develop in MATLAB, the generated code is C, right? So I used to debug MATLAB generated code also. Okay, no one used to do it in my team because they never started their journey with C. I started my journey with C. I used to debug my code in C also. I never looked into how the model is working. So I would suggest start with C. Very important for embedded engineer. Have I answered your question?
Yes, sir. Yeah.
Okay, thank you. Anything else? Okay, I think we are also out of time. I'll stop presenting. Okay, and I'll give back this to the host.
Okay. Thank you, Mr. Sawant, for sharing your valuable insights and expertise with us today. So we truly appreciate your time and the enrichment perspective you have provided on embedded intelligence in electric vehicle. And I also thank you all the participants for joining today's masterclass and your active participation. Before you leave, we kindly request you to fill out the attendance form and the certification link to mark your presence in the session. And I already shared the links in the chat box. For any query or support, please feel free to write us at support@diyguru.org, or you can also drop your contact details in the chat if you have any query. Our DIY Guru team will reach out to you. And once again, Mr. Sawant, thank you so much for being a part of the session and give us an insightful journey. We look
Yeah,
forward to continue your engagement with the DIY Guru. Yeah,
sure.
thank you, everyone.